I myself Kantraj, Assistant Professor of Physics, Government First Aid College, Malur. This is a class for BSc Physics, third semester, Bangalore University North. The title of this paper is Electricity and Magnetism. So today we are going to discuss a few problems in transient currents. So the main learning objectives of this chapter is to calculate the self-inductance of a coil and energy stored in the inductors, and also determine the time constant and the value of inductance in LR circuits, and to find out the time constant in CR circuit and also the final current in the CR circuits. So let us take the examples. Problem 1. The current in the coil of self-inductance 15 Henry changes at the rate of 5 amperes per second. Calculate the induced EMF. If the final current is 80 amperes, calculate the magnetic energy stored in the inductor. So what they are given the problem is, so they are given the self-inductance of the coil is 15 Henry and the rate of change, that is changes the rate of current 5 amperes per second. So calculate the induced EMF. Induced EMF means, so E is equal to L di by dt. We have an expression from self-inductance of the coil. And also if the final current is 80 amperes, calculate the magnetic energy stored in the inductors. So two things you should be calculated. One is nothing but induced EMF, and second one is what is the energy stored in the inductor. So they are given 15 amperes and di by dt is 5 amperes per second, and the current they are given 80 amperes. So E is equal to L di by dt is an expression of self-inductance of the coil. So E, which is equal, substituting the value of L 15 and di by dt is nothing but 5. Substituting that, you can calculate that is 75 volts. You will get the induced EMF in a given coil. And also the energy stored in the inductor can be written as E is equal to, we have derived that E is equal to half times Li square, where L is the inductance of the coil and I is the maximum current in the coil. So half into 15 into 80 square, which is equal to 40 kilojoules of energy, which I can see in your inductor. This is what is energy stored, magnetic energy stored in the inductor is 40 kilojoules. So coming to the second problem, a solenoid of 500 turns is wounded on an iron core of relative permeability 800. The length and the radius of the solenoid are 40 cm and 3 cm respectively. Calculate the average EMF induced in the solenoid if the current it changes from 0 to 3 amperes in 0.4 seconds. So when you see the solenoid, it is made up of number of turns, and such that if mu is called as permeability of free space, mu r is called as relative permeability of a material. So they are given the radius of the coil is 40 cm and 3 cm respectively, and length and radius. So you want to calculate the EMF induced, average EMF induced the solenoid. So let us take given n is equal to 500 turns and mu r, it's a permeability of relative permeability 800, and length of the coil is given 40 cm and radius of the coil is 3 cm. 40 cm can be written as 0.4 meter and 3 centimeters can be written as 0.03 meters. So the current is changes from, if the solenoid the current changes from 0 to 3 amperes, so di is equal to 3 minus 0, which is nothing but 3 amperes. So change of current will be 3 amperes at the time dt is equal to 0.4 seconds. We know the self-inductance of the coil can be written as L is equal to mu n square A L. So where mu is equal to, it is mu naught into mu r, it is the permeability of free space and relative permeability, we can combine to get the equation. And where A is the area of the coil, we can write it the coil, circular coil, it is pi r square, and n is nothing but number of turns per unit length. So n I can write it as n divided by L. Substituting this equation, we get that mu naught mu r n square divided by pi square r square and divided by L, the final expression of this concept. So now I can substitute the value here. Mu naught is equal to 4 pi 10 to the power of minus 7, substituting here, and mu r is 800 and n square is 500 square into pi again 3.14 into 0.03 whole square divided by 0.4. So after substituting all this, calculated 1.77 Henry, we get the inductance value. Therefore, once if we get the inductance L is equal to 1.77 Henry, then EMF induced, average EMF induced E is equal to L di by dt. So that is substituting the value of L, and we are given as rate of change of current di 3 divided by 0.4. If we substitute here, we will get that 13.27 volts, that is induced EMF in the coil. So next problem, we have a circuit like LR circuit and CR circuits. So let us take for this problem in LR circuits. A coil having a resistance of 100 ohms and inductance 30 Henry is connected across 20 volts battery. Find the time constant of the circuit and B current after 0.4 seconds. When looking this the problem, we have an resistance 100 ohms and 30 ohms. It is connected in series. So once it is series, you want to calculate what is the growth in the inductance. So in that case, first thing I want to calculate what is the time constant of circuit, and B is what is the current after 0.4 seconds you want to calculate. So R is equal to the given 100 ohms, L is equal to 30 Henry, V is equal to 20 volts and T is equal to 0.4 seconds. So first you want to calculate the time constant, and second one is a current after 0.4 seconds. So from the definition, or from your derived expression for a time constant, tau is equal to L divided by R in RL circuits. So substituting the R value, L value 30 and R value 100, we will get 0.3 seconds, that is the tau. And the equation, the current at any instant during the growth is given by I is equal to I naught 1 minus e raised to the power of minus R by L into T. So we are going to take separately. R by L into T is nothing but, that is T is 0.3 they are given, and that is R by L is 30 divided by 100, which is equal to 0.3, and time they are given as 0.4, it is 0.12. So this is R by L into T value. Now if we substitute this one in this equation, I is equal to I naught 1 minus e raised to the power of minus 0.12. So this is equal to I naught 1 divided by minus 1 minus 1 divided by 1.127, because the value of e to the power of 0.12 is nothing but 1.127. So our I naught into 1 minus 1 divided by 1.127 is 0.886. So if you simplify this, we will get I naught is equal to I naught 0.114 amperes, or just the equation. We know that the maximum current in the circuit I naught is equal to V divided by R. So looking to the circuit, they are given V is equal to 20 volts and R they are given as 100 ohms. Substitute this value, you will get 0.2 amperes. Current after the 0.4 seconds, I is equal to 0.2 into 0.114. Substituting these values, you will get 0.0228 amperes, or 22.8 milliamperes of current, which I am going to calculate the current after the 0.4 seconds. This is, we can calculate the current. The resistor of next problem, the resistor of 3 mega ohms is connected in series with a capacitor of 5 microfarads and a battery of EMF 20 volts. So calculate or determine first time constant. B, fraction of final charge remains at t is equal to 19 seconds. C, after how much time of charge on the capacitor is maximum. So when you look this problem, we have the combinations of resistor and capacitor, and see that it is how much the fraction of charge remains at t is equal to 19 second means it is understood that it is the charging of capacitor or growth of capacitor. So they are given R is equal to 3 mega, 3 mega means 3 10 to the power of 6, and E is equal to 20 volts, C is equal to 5 microfarads. So first thing you want to calculate tau. So when you have the Q by Q naught, when T is equal to 19, T is equal to determine, that is when Q is equal to Q naught. A, T is equal to RC, tau is equal to RC, that is 3 into 10 to the power of 6 and 5 into 10 to the power minus 6, which you will get substituting the value of R and C will get 15 seconds, that is the time constant of RC circuit. And B, we have Q is equal to Q naught, that is 1 minus e raised to the power of minus t divided by, sorry, the expression for a charge for decay, charging or the growth in your CR circuit. When t is equal to 19 seconds, Q by Q naught is equal to 1 minus e raised to the power of minus t divided by CR. Substituting the value here, 1 minus e raised to the power of 1.266, that is t divided by CR value. 19 divided by 15, you will get 1.266. So once if we calculate this, send it to the denominator, 1 divided by e raised to the power of 1.266, and simplifying this, you will get 0.718, which is equal to 71.8%. That is Q by Q naught value, the charging, that what the fraction of final charge, Q by Q naught is nothing but fraction of final charge. After how much time the charge on the capacitor is maximum? I want to take that the charge is said to be maximum. At what time the capacitor is going to get the maximum value? So we know the charges reaches the maximum value after the nearly 5 times the constant, as we are done in the theory, that is 5 times of lambda or 5 times of tau. T is equal to 5 times of t. So we know that t is equal to, t you got it as 15 seconds tau, and 5 into 15, which is equal to 75 seconds, will reach the maximum value of charge which is stored in the capacitor. This is what we can see the problem when you say take about your CR circuits. Let us take one more problem. In LR circuit, the current attains 1/3 of its maximum value in 4 seconds. What is the time constant? If the value of resistance is 10 ohms, calculate L. So looking to the given data, I is equal to I naught by 3 they are given, that is 1/3 of its maximum value, and T is equal to 4 seconds they are given, and R is equal to 10 ohms, L is equal to, you want to determine. So we know that charging, that is LR circuit, it attains the maximum value means it is I is equal to I naught 1 minus e raised to the power minus R divided by L into T. So we know I from the given data I is equal to I naught by 3, and I naught, substituting this, 1 minus e raised to the power of minus R by L into T. Keeping the same thing here, substituting they are given T is equal to 4 seconds. So 1 by 3, I naught cancels, 1 by 3 is equal to 1 minus e raised to the power of 4 times R divided by L. Or I send to this side, e to the power of minus 4 R by L is equal to 1 minus 1 minus of 1 by 3, which is equal to 2 by 3. Or E is equal to 4 R divided by L. If a reciprocal of this, it is 3 by 2, because it is 1 divided by the value, so it will become minus sign to become plus. So it is 2 by 3 means it is 3 by 2. So taking log on both sides, log and exponential get cancels. So 4R divided by L is equal to log of 3 by 2. So 4R by L is equal to, it is the base E value actually. When you want to convert base 10, it is 2.303 into log of 3 by 2 is nothing but 0.176. So 4 into, that is 40 divided by 4R, R is 10 ohms. So 40 divided by, if you multiply this, you will get 0.405. So that gives about your inductance value L is equal to 98.7 henries. So this way you can calculate any one of the parameters, either R or L, by using these expressions, taking the log on both sides, so we can calculate the L value. So another capacitance in the case of discharging of capacitor, a 50 microfarad of capacitor is charged, then discharged through a resistance of 20 mega ohms. Calculate the time constant in which the charge on the capacitor decreases to half of its initial value. So by taking this problem, let us think that some amount of has been charged in the capacitor initially. So I want to calculate that which charge of the capacitor decreases to half of its initial value. So let us take the given data. C is equal to 50 microfarads they are given, and R is equal to 20 mega ohms they are given, 10 to the power of 6. Micro is 10 to the power of minus 6. Q they are given as Q naught by 2. So you want to calculate the time constant T. So we know that Q is equal to Q naught e raised to the power of minus T divided by CR is an expression to calculate about the charge on dk. So as the given thing, Q is equal to Q naught by 2, which is equal to Q naught e raised to the power of minus T divided by C into R, it gives us 1000. So Q naught get cancels off, which is equal to e raised to the power of minus T divided by 1000, or which you take the reciprocal, it becomes a positive value, e raised to the power of T divided by 1000, which is equal to 2. Or T divided by, taking the log on both sides, T divided by 1000 is equal to 2.303 log of 2. Directly I am going to convert in the terms of base 10. Or T is equal to 2.303 into 0.3010 into 1000. We will get 693.2 seconds as the time for initially what the charges has been taken for that. It is the capacitor decreases half of its initial value. So that is the time has to be taken. So this way you can solve the different problems in the transient currents. So the references are made as different home core publications, Sunstar and some e-resources. We have taken the references to solve these problems. Thank you one and all.